So when I post the solution, you all see the solution member. No, it needs to be what? Okay, that's not getting from McMaster. We have critical thinkers. Maybe in toilet water, if your toilet water, you can be like that. Toilet water, yeah, water, thank you. We are McMaster. Shit, I hope this is not recorded. It is whatever. Right? Okay, so let's construct a free body diagram that you and me what? Agree. Yabo. Okay, let's do it. So now I'm going to construct the diagram for the crate. Let's do this properly. How's that? Okay, let's do this properly. Okay. And we are going to draw the crate. All right. And over here is where our weight is. And this is where we have our, this is our point G. And this is where we have our 150 pounds. Now, point D is over here. And point B is over here. So this load should be where? Going what? Upwards. Yes or no? Right? So this is so-called our dy. Let me zoom in again. And this is our by. Okay. Then after that, we draw our links. Right? So we know that our link should be under what? Tension or compression? It should be under compression. Okay, it's compression then. Both sides. Okay, it's under compression. So this is my CY. This is my AY. Right? And this is still my BY. And this is my DY. And we know what we are given is we have a load or a moment going over here. The moment applied is equal to 650 pound-feet. Right? And I'm going to assume over here, this is my DX. And cross opposite on the crane, this is my DX over here. Because action equal to what? Reaction. Are we clear? Okay. So because the structure, right? I'll let you guys finish copying first before I keep on playing. Okay. So when that's the case, I have a two-coordinate system that we're going to use. So this will be known as my T. And over here, this will be known as my N. Okay. So I decide to pick that coordinate system. That is my T. And that is my what? Direction of my T, positive T. And positive N. And then I'm going to declare anti-clockwise is positive. Okay, so I'm going to use this notation. Okay, so the first thing we do is we are going to consider our member CD to determine our dx. Okay, we want to find what is our dx first. Okay, so we just focus on member CD. Okay, we just focus on member C. So what we know is anything that's rotating anti-clockwise, moment from point C, right, is equal to 0. Okay, so what we are doing down here is we are doing so-called static analysis down here. First, okay. So you will have, so at point C, you have minus 650, right? Because going clockwise, then minus dx, and the length is 4dx. So from here, dx will be equal to minus 650 divided by 4. So this is equal to 650 divided by 4. Is equal to minus 162.5 ounce. Negative means our assumed direction is what? It's wrong. So over here, now when you have something like this, do not erase, okay? All you need to do is just cancel. And this is the dx direction. And when that's the case, you just cancel over here. This is your dx. Are we clear? Okay, don't like. So now we have two more equations to use. Questions so far, are we okay? Yes. Say it again. For the first part, we are doing static analysis to determine what is dx first, because we don't know what is dx. That's why you have to do static analysis. Okay. Now, the next thing that we are going to do is we are going to do, there are two equations that we're going to use now. So we are going to do summation about forces in the tangential direction is equal to m AGT. Okay. And the other one we are going to use is summation of forces in the normal direction is equal to m AGN. Okay. Now, both of these, AGT and AGN, okay, are curvilinear equations. So if we look at the curvilinear equation, okay, what does it look like? So you have AGN will be equal to omega squared R. Does this look familiar? Yes or no? Then you have AGT is equal to alpha multiplied by R. Okay, so we just completed this in our term test. Okay. So if we go back to look at our value, okay, we know that omega is 8 radians per second. So what we need to do is now we know that this is equal to 8 squared. And the radius is based on the length, and it's going to be 4 feet. So what we have over here, so 8 squared times 4 is equal to 256 feet per second squared. AGT, what we have is we don't know our alpha, but we know our radius. Our radius is equal to 4 alpha. Okay. So this is our equation number 1. Okay. So from here, we do summation about forces in the tangential direction is equal to M A G T. Okay. So this will be equal to, so in the tangential direction now, over here, sorry, I'm now, do not, I'm sorry, okay. So we are going to consider the crate now. Yeah, we're going to consider. So we are going to assume members CD, DB, and AB are rigid body. Okay. So what do we mean by that? So if we were to look into the diagram, okay, let me copy and paste the diagram so you can see better. So all this are all your what? Rigid body. Means doing any motion, the deformation is a what? Straight line. Are we clear? So if this thing were to bend, all these are straight lines. Are we clear? I know this is far from reality, okay, but to simplify our calculation, that is what we are going to what? Assume. Okay. So now let me start on a new page. Okay. I will need this diagram over here. Okay, I'm going to copy this whole diagram. Please copy, please copy. So what we are going to do now is we are going to have summation about forces in the tangential direction is equal to M A G T. Okay, so as I said, we are going to focus on the crate. So dx we calculated using static analysis is 162.5. So the mass is equal to 150 divided by 32.2. Okay. So AGT we know is known as 4 what? Alpha. Okay. So from here, alpha is equal to 162.5 multiplied by 32.2 divided by 150 and divide by 4. So 162.5, 2.2 divided by 150 divided by 4 is equal to 8.8. 162.5 times by 32.2 divided by 150 divided by 4. 8.72 radians per second squared. Now, n is pointing down is because we are going through the what? Center of curvature, yes or no, right? So if you can go back to here, right? And over here, this is the center of curvature for the curvilinear path. Okay, so that's why it's pointing downwards. It's not pointing what? Upwards. Are we clear? We have seen this before in term test the topic in acceleration. Okay. So coming back to our problem over here, That's why N is pointing down. So next we're going to do real straightforward. This is easy stuff. This is like much easier than your term test.